let's talk about Channelizer. Channelizer extends your visibility, your Wi-Fi visibility, from traditional web-based monitoring systems to what's actually happening in the RF environment for a client device. So this is just augmenting what you already have. With so many devices now wirelessly connected to the network, we all need a tool that can display the actual congestion and help you identify it in that specific RF environment. So if you suspect RF interference, well, plug in a Y-Spy spectrum analyzer or a Wi-Fi clarity spectrum analyzer, and this will help you show RF activity from those non-Wi-Fi and Wi-Fi transmitters alike. So I'm going to just kind of go over a just brief real live demo, and then we'll go into a capture to kind of to show how things are displayed in the actual environment. Okay, so this is capturing the spectrum analysis data, and we are also showing the number of radios and client devices that are displaying, and we get this from the Wi-Fi network interface card that is plugged in as well. So if you have a spectrum analyzer, you can get details like this, where we say the channel airtime exceeded a threshold, we identify the access points and the top talkers on that particular channel, and we highlight what top talker it was. Okay. Now these network interface adapters, you can plug up to 3 in, and we are going to scan all the channels that are currently in use. And as you navigate around, so like let's say I know that this laptop is connected to this particular SSID, I can click on it and get all sorts of details. So this laptop is connected to this radio broadcasting this network. So you may have multiple radios broadcasting a shared SSID, and typically that's here. If there is an SSID that has multiple radios and lots of clients, you can navigate those here. And as you click in, a couple things are going to happen. We're going to assign one of the USB network interface cards to that radio, and we're just going to monitor it constantly. And we're going to send the other 2 USB network interface cards across the other bands, or split up the channels that you want to scan. This is going to help us kind of keep real-time updates around what's happening, but it's also going to let us monitor the access point that you're looking at specifically. So let's say you have a junior technician that is just out in the wild, and you need that technician to reliably capture something. You say, hey, go walk into that environment. This is immediately going to show the nearby devices, and you're going to want him to stand next to whatever he's trying to troubleshoot, and you're going to say, okay, once you see that particular device, click on it, and that's it, because Channelizer is already going to start capturing this entire session into a single PCAP file. And so that particular device, you're going to see the signal strength, you're going to see the signal strength of the access point that it's connected to. So what we expect is to see something that is, a static line here. But if that device is moving and the technician is moving with it, like following it, we'll see the AP signal strength change and the network signal strength stay kind of the same if you have good coverage throughout the location. And then we'll track the retries, the airtime, and even the MCS rates for just the client and the AP. And we'll also track the signal to noise ratio as reported by a client device. Okay, all this is exceptionally useful in addition to just the spectrum data that we get. And this is the 2.4 and the 5 gigahertz. With the Wi-Fi clarity, you'll be able to do the 2.4, 5 gigahertz, and 6 gigahertz. Okay, I've opened up a capture, and I'm going to pretend like I received this from a technician who was on site. And what's nice about this is the way that we've organized this is any device that is nearby that is Wi-Fi, we're going to show whatever is closest, or whatever that technician was closest to, so you can kind of get an idea of what the technician was troubleshooting without them having to, send you a MAC address or anything else like that. You may know the SSID just because that's the one you typically work with, and typically those devices will show up here as well. Over here, we're going to give you a brief highlight of how many clients were on a specific channel. And if it's a 2.4 gigahertz channel, you'll see it purple here. And then we'll display the airtime of that particular channel below. And this can change and look different as you go through, but really it's just kind of meant to help you see how your clients have distributed themselves. And if a bunch of them are on the 2.4 gigahertz, that's what you need to know. You need to know that they're preferring the 2.4 gigahertz for whatever reason that is. Or you may see a bunch of clients all on the same 5 gigahertz channel and the airtime be high. And that likely is an indication that you have too many access points on the same channel with a bunch of client devices. Maybe changing the channels a little bit up will shake it up and distribute the airtime hit from all those client devices. All right, so if you do know the network name, click on that here. And that's when we're going to parse the entire PCAP for things that might be useful for you. Now, the technician, as they were capturing, likely saw all of these in real time as they were capturing it. But if you just receive a PCAP or you download a PCAP or however you got it, if you open it up and channelize it, this is where we're going to start highlighting specific events here. Now, some of the events will be high channel overlap. And this is when we say, okay, on this channel, we saw these access points. Now, we're smart about this. We're only going to look at the top 5 strongest SSIDs, and we're only going to alert for those one time. So as you're walking around, you may see those high channel overlaps appear again and again and again. Now, that's just going to happen based on your thresholds that you set in the tool. But we are smart about it, and we only will alert when it is one of the strongest RSSIs, the signal strength that we see, and we also see that it's nearby another strong access point. Okay, so let's go to inadequate signal strength. This is where we're going to call out the SSID that we saw low signal strength for, and you can toggle between the 2.4 and 5 gigahertz just to get an idea. But if you look at the icon here, you'll notice that we caught it twice in this selected time span. So it went below our threshold 2 times. Okay. And in this particular capture, if you do have spectrum analysis data, you can turn all of that on if you want. Sometimes it makes it a little noisy. It doesn't really matter. But this is kind of a way for you to investigate the low signal strength. So yes, there was a point in time in which the signal strength was low. That is a little bit of a concern, but I see a couple other things that were of interest here. And we'll go back to the assessment page here. And we'll move the time span to that point in time. And what's going to happen is we're going to identify the device that had that particular event. And you can hover over it as well, and we'll call out a failed connection. And you can see that a specific device was having failed connection issues. You can click on it. So in this particular, so now that we've clicked on it, you'll notice that a whole bunch of other icons popped up. There's a bunch of little blue dudes running around. This is every single time a device roamed. Okay. Now we're not going to capture every single roam, but when we see a device on a new access point, we can assume that it roamed. And if we do capture it, we'll call it a roam. And if we didn't capture the actual, roam event, we'll say it's an assumed roam. Okay. But we did see a bunch of failed connections, and we give the reason code for that failed connection. So there's a deauthentication, and you can click on that and it'll say the reason code, or we'll display it the best that we can in this small table here. If you are interested, you can send this straight to Wireshark like this, dig even deeper into all the retries and whatever things you need to do in Wireshark. Very easy to do. But this is kind of where Channelizer got so much better than just spectrum analysis. Because with just spectrum analysis, you could see the signal strength, but like you couldn't differentiate between all the devices, who was talking a lot, how much management overhead, what was the airtime of Wi-Fi devices. All this stuff is super easy with the next version of Channelizer. Okay. So this particular device, if you know what it is and you want to, be able to find it again, give it a nickname. Say, we'll call this problem device number 1. Now, throughout the tool, we'll show the nickname as problem device number 1, and we'll save it. So when you open up other captures, you'll see problem device number 1 pop up as an alias for that. But I want to draw your attention to what we see here for this particular device. Now, across the top, the client signal strength is largely the same, okay? So we know that the technician or whoever was performing the capture of this device, they were nearby, okay? And you can see that the signal strength of, what that client was connected to was dropping. So we tracked that. We knew it was connected to an access point because these network interface cards capture all traffic. So we follow it, and we follow it smart. No one has to configure anything. We just know that you are looking at that MAC address, and we send all the other USB network interface cards that you have plugged in. We send those hunting for it, proactively looking for it. What's the next channel that it's going to run to? We're looking at those first, okay? All right, so we see the signal strength drop, and what should happen does happen. Immediately, the signal strength jumps up, and we see that it roamed. Okay, that's what this little guy is. Okay, and we can even see at some points there was low signal strength for that network. So the technician following the client device, they walked into a low signal strength area. That is visible here. You can track that somewhere here. It looks like we lost the connection mostly around here, and so there was an alert. The other things that I find very useful about this tool is, we saw the signal strength drop to about -62, but as the signal strength was dropping, you'll notice that the retries were going up as well. And this is going to be true throughout the troubleshooting process here. Is we track, low signal strength and match it to high retry rates. Okay, and we also track when there was high airtime. Okay, so we track that per client device. If you want to just look at the radio itself, we'll track all the roams that were happening, and then we'll also track other things like high retry ratios. So if there was high retry rates for that particular access point, we show that, and then we will track the data rates that this device was doing. Okay, let's go back to the spectrum view. So as a device is going around the environment, and if you do want to see where the access points were, you can see the little boxes that are drawn across the top. You can turn those off and just look at the raw spectrum data. Now, what I like about this particular way of displaying it is we can see that a device was going, a Wi-Fi device, and the signal strength is high. It's tall, right? And anytime we see like brighter colors like greens and reds in the spectrum, if it is tall, that means it is loud and constant, okay? When it's just blue, we can see that it's not as constant. We can see that it was constant for a brief period of time, but for the whole time span, it was not talking the whole time. Okay. If you do want to shorten the time span, you can do that just like you could do in Channelizer, older versions of Channelizer. And you can go back to these points in time and you'll see that, in a 30-second window, we saw much, much brighter and constant noises. And that's really what we are looking for in terms of congestion, in terms of troubleshooting. So something was doing a throughput test, most likely the same thing here. It's similar RSSI, similar height. We see it jumping between bands. So it's in the 5 gigahertz, and then as we go to other parts of the capture, we'll actually see around where there was low signal strength, it jumped to the 2.4 gigahertz. Okay, and all of this can be reflected in terms of our assessment page and in the network page, where we have taken all of the network information and we have combined it into one single tool in which we can show the current trace and the density and other things like that, and drill down for every single access point and every single client. So back to the problem device number 1, and we can see the entire story for that client device and what it essentially experienced. Sometimes the fix is going to be, yeah, we saw too many access points on the same channel. Let's divvy those up. And sometimes you'll look at the assessment page here and you'll say, wow, we actually have, all of our devices in the 5 gigahertz. Or, you'll look at a different capture and you'll be like, wow, actually, you know what? We saw a bunch of devices in the 2.4 gigahertz. Okay. So depending on what your RF environment is like, this tool is going to adapt to it, and it's going to be smart about how it troubleshoots and helps you understand more about your RF environment. Thanks for watching, and hope to hear from you.